In this video we're going to work out the volume of this cylinder that has been sliced across by this plane. So when you look at this plane, if you draw your ZX graph, so your ZX graph, it has an intercept of 4, a gradient of -2. So a gradient of 4, a gradient of -2, and this line here is really this line here. Okay, so it has been sliced across by this plane, and then looking at this you can see it's a circle of radius 3. So we're going to work out the volume of this. So volume equals, so set up our triple integral, and by the way this is an inefficient way of doing it. Later on I will show you a more efficient polar coordinates way. So this is our Cartesian way, dz, and then let's do it as dy dx. So dz would mean you're moving parallel to the z-axis, and you enter you enter z equals 0, and then you leave the plane. So you enter z equals 0, and then you leave the plane. So you enter z equals 0, and then you leave the plane. You leave the plane. Well, what's the equation of this plane? Well, the equation of this plane is z equals 4 minus 2x. So you enter z equals 0, and then you leave the plane. You enter z equals 0, and then you leave the plane. And then in terms of the y, hang on, let me erase this, let me clean this up. So in terms of the y, is going to be y equals something, and you're moving parallel to the y-axis. You're moving parallel to the y-axis. So you enter y equals this semicircle here, and then you leave the upper semicircle, and then you enter this semicircle here, the negative semicircle, and then you leave the positive semicircle. So looking at this circle, hang on. Looking at this circle, the equation of this circle is given by this, and because it's y equals something, we need to make y the subject. So y equals, take away x squared, and then when you square root you get the positive version and the negative version. Well, this is the positive version, and this is the negative version. And then when you enter, you can see you entered the negative version, and then you leave the positive version. You enter the negative version, and then you leave the positive version. So this is negative root 9 minus x squared, and this will be the positive version, root 9 minus x squared. And once you've taken care of the once you've taken care of the y-axis, then you've got to take care of the x. So x equals something, You can see that that you're actually integrating from -3 to +3. So in terms of the x, it would be from -3 to +3. So this thing here will then give you the volume of this solid. So let's evaluate this. So the volume of the solid is given by this. So now it's just a matter of integrating this. So integrating it, there's a 1 here. When you integrate this with respect to z, it will then give you z from 0 to this plane, from 0 to the plane. So put this into here, that will then give you this, and then now integrate it with respect to y. So that will give you 4y and then 2xy. So integrating this will then give you this thing here, from the negative version to the positive version. And then put this into here, put this into here, that will then give you this, and then put this into here, put this into here, that will then give you this thing here. And then I think you tidy it up, tidy this up. So looking, hang on, let me think, tidy this up. This is exactly the same as this, and then you've got 4 lots giving you 8 lots, and then this is exactly the same as, sorry, hang on, well, merging these two together would then give us this thing here, and then now integrate it with respect to hang on, let me think, oh sorry, here you've got one thing, take away another thing, so that's the same as you integrating the first thing, because you would drag this 8 out, and then that would be the same as you integrating this thing, and then you drag the 4 out. So so let's integrate these two things separately. So this is one integral, and this is another integral. Okay, this one here, hang on, this one here is easy to integrate, because this is near enough the derivative of this thing here. We know that we've done this before. This thing here is easy to integrate. This thing here, because there isn't an x here, this is much harder to integrate. We are going to, well, if you really want to integrate this is actually hard to integrate because there is no x here. If you have an x, then it's a lot easier. But because there is no x, it's a lot harder, and you have to use trigonometric substitution in order to integrate this. But we're going to cheat, because if you look at the graph, y equals this thing. So let me square this. So looking at this, y squared equals 9 minus x squared. Add x squared. So you know this is going to be a circle of radius 3. So if you draw the line, it will look. If you draw that graph, it will look like this: radius of 3. And when you're integrating from negative, so when you make y the subject, you're going to get the positive version. So if you rearrange this to make y the subject, it will give you this. Hang on. You get the positive version and the negative version. Well, the positive version is this, the negative version is this, but we don't care about the negative version because this is a positive version. And when you're integrating the positive version from negative 3 to 3, you're really looking at half of a circle. So rather than using trigonometric substitution, which we've done many times, and I'm expecting you to be able to do this by now, we are just going to use half of that circle, radius 3. So pi r squared divided by 2, because it's half of a circle. So it's just a shortcut rather than having to use trigonometric substitution. Okay, so let's just know that this is half of a circle. Okay, and when you integrate this, and I'm expecting you to be able to integrate this, it will then give you this thing here. And when you put 3 into here, 9 take away 3 squared, it would be 0. The whole thing would be 0. When you put negative 3 into here, even though it's a negative, the whole thing will still be 0. Well, anyway, overall the answer would be this. So the volume is 36 pi. Now let's use polar coordinates, which I will continue in the next video. Okay.